So the bullet, what happens when it is finally, when bullet is inside this. And finally what will happen, it will be problem very simple. If you can understand the situation very easy, within I think 2-3 steps we'll end up with answer. Oh. Finally it emerges, no? Here it emerges, is telling. It will emerge with a certain speed that is available. At the bottom to V equal to 80 at the top. Okay, this is the velocity. So somewhere here, the velocity, let it be, say, V1. The moment it enters, it will have velocity U, and when it emerges out, it will have V. And there is a spelling. Bullet reduces uniformly. Within the bar, speed of the bullet reduces uniformly. Uniformly means there will be uniform retardation. Why do that retardation? A1, because the force acting on the bullet in this direction. And similarly, how the force on the bar will act, the force on the bar will be in this direction. So let's calculate that retardation. So we know this width of the thickness of the bullet, so thickness of the bar. So then using the formula, V square minus U square equal to minus 2 minus A1 into D. We know VU, I'll get A1. If I know A1, I can calculate the force. What is the retarding force? M1 A1. Give me the value of A1. A1 will be 9,000 meter per second square. Then what is the F? F will be how much? M1 into A1. Multiply this, we'll get 180 Newton. Then what should be the mass of the bar? So when F should be equal to M2G, so you know 180, and this is M2, this is 10. 18 kg. If the mass of the bar is less than this, it will lose contact. A very, very simple problem. You do get some applications. Just be careful. If I project with a speed greater than, if M2 is 18 kg, if I increase the speed, you definitely lose contact. I'll connect this to the spring, this particular. So you do have some application problem where this will be connected. Find the maximum elongation of this. If I increase the speed, if I double the speed, you definitely M2 will lose contact. When it loses contact, what is the state of it? It'll go and compress the spring. Next, further, we'll discuss some application problems. Now, the effect of G will not, the overall, it will be like this. Within the bar, speed of bullet reduces uniformly, that one. The effect of G will not be there. The maximum, it will be due to resistance of that one. Look at the mass of the bullet, 20 gram, no? Only the resistance by the material of the bar to the bullet has to be taken here.